This is a continuation of our one-step equations and inequalities. In this case, when a number and a letter are next to each other, it means we're going to multiply. So to undo multiply, I always say rewrite the problem before dividing because it's real easy to get confused. Now I know a lot of my lazy people are going to be like, whatever, I know, but you know, if you were in my class, I'd really want you to do this because after all the years of teaching, this is a mistake I see a lot. So in this case, to undo something that's multiplied to x, I would divide it. So I divide by the exact number, not the opposite like I did with addition and subtraction. The reason I use the exact same is what am I trying to get here? I'm not trying to get a 0x, I'm trying to get a 1x. And 3 divided by 3 will give me a 1. If I would have used a negative, it'd have been a -1, and that's no good. So now I have x equals 5. Now remember earlier, you can have 1x is the exact same thing as regular x. If you're doing the inequality, again, the same idea occurs. We're going to divide by 3. But look what happens here. If I just start dividing up here, I don't remember when I go back into this problem to check, did this problem start off as a fraction or did I create the fraction? Now, I know you're like, I'm not going to forget that. But I'm telling you, when you're tired, I really am telling you, you will forget, or it's just a common thing to have happen. So again, I'll divide by 3. X is less than 5. And with the inequalities, they usually like us to put them on the number line. So I have 4, 5, 6. And I was off the screen there a little, sorry. And then I open it up because there's no equal sign there. And I go to the left. All right, now let's talk about those fractions that you guys are sometimes scared of. The fractions. You are going to look at this fraction not as a fraction, but as a division. It's not x over 2, it's actually x divided by 2. And just like when I said 3 was multiplied by x, we had to divide, the opposite is true, that if we have divide, we're going to eliminate the divide by multiplying. So I'm going to multiply by 2. So when I show multiplication in algebra, we don't use that x anymore because then we get confused with the variable. So you just have this little dot. And you're going to do the same thing over here. Now, on this side, what is the 2 is actually doing this. It's multiplying to the x, 2 times x. But then it has the divided by 2 on the bottom, which ultimately leaves us to 1x because they cancel. On this side, you would just have -3 times 2. That's a -6. Now, you do not have to show this step, but a lot of people just go right here and just cancel it out. What I want to make sure you don't do is multiply the 2 with the x and the bottom 2. With fractions or anything that looks like a fraction, the bottoms of fractions will only multiply with another bottom of a fraction. So this is a 2, not something that's on the bottom of a fraction, like something over 2. So that's why that stays still. And again, we could do the same thing over here by multiplying by 2 on both sides. I'd get, and we're just going to go ahead and cut it out right now. So I'll have x less than or equal to -6. And again, if I'm on the negative side of this and I have a -6, above it would be a -5, below it would be a -7. We're going to use the filled in circle because of the line underneath. And it's less than, because I see like a little slanted L there, and less than on the number line goes to the left. Now, we are going to talk about one more type and then this video is over. Now, doesn't mean your math is over, but your video is over. So, in this case, this is a one step. What is in front of this -x is actually a -1x equals 5. So we just write it like that, it means the same thing. So when we're doing this, you can do a couple different things here. This is the same thing as x divided by -1 equals 5 as well. These two things are the same. So one person might look at it like this and say, well, it's multiplying, I'm going to divide both sides by -1, and therefore I'll get x equals -5, which is correct. But this person may have looked at it like it's a division, and when they multiplied by -1, Boom. Same thing ends up giving them the answer, -5. So it really doesn't matter if you multiply or divide, but, one big bonus problem here. When you multiply or divide by a negative with inequalities, that's the first time things change. And that's why I say this one's different. Because here, anytime you divide or multiply by a negative number, guess what? The sign has to flip. So here, if I divide by -1, now I'm going to have a positive x, but instead of less than, I'm now going to change it to greater than -5. Now, I know some of you are like, well, I knew that. And you might have, but guess what? Do you know why? Because a lot of people will tell me, because my teacher told me. And guess what? That will get you good answers, but it won't help you remember it. So you know how sometimes I say, are you going to remember this from last year? And you say, that was all the way last year. But if I say, what's 1 + 1? You know it. It's 2. And I said, but you learned that all the way back when you were a kid. And guess what? The difference is when you understand the concept, you don't forget because you can re-explain it to yourself in your brain. But if you don't understand the concept and you're only doing things because I tell you to, you're going to lose it, okay? Now, I'm going to explain why this happens. And what happens here is this. So think of a number line, all right? The numbers on the left are smaller to the numbers on the right. Agreed? I agree. So 2 is less than 6. What happens if I add a 1 to both sides? So let's just go through that. 2 is less than 6. Well, if I add a 1 to both sides, now I have 3 is less than 6. And I look on my number line. Is 3 still smaller than 6? Yep, it's still true. Well, what if I subtract a 1 from both sides? So I'll start again. I'll say, okay, 2 is less than 6. I'm going to subtract 1 from both sides. Now I have 1 is less than 5. Well, let's look back at my number line. Is 1 on the left side of 5? It sure is. All right, I know what you're doing, Miss Chestnut. I know. But let's try 2 is less than 6. Let's multiply it by 2. Okay, I'm going to multiply it by 2. When I multiply by 2, I get 4 is less than 12. Is 4 smaller than 12? Sure is. All right, well, let's divide. 2 divided by 2 is less than 6 divided by 2. Is 1 smaller than 3? Yeah. So all of these happen, and we're still good. So where does this flipping of the negative come? Well, look what happens when I take that 2 is less than 6, and this time I divide it by a -1. If I divide it by a -1, I get a -2, and I get a -6. Now, is -2 smaller than -6? Look back at your number line. -2 is on the right side of -6. Oh no. So this is false. So the reason we have to flip this sign is to maintain the truth of the equation or the inequality. So in this case, -2 is actually bigger than -6. Because if you look at your number line, once you cross over that 0, 2 is now on the left side of the 1 versus on the positive end, 2 is on the right side. So when we are dividing or multiplying by a negative, that is why we flip the signs. Okay, thank you.